In the previous video, we discussed the new additions to the Swift language as introduced in WWDC 2015. In this video, we'll introduce the concept of functional programming in Swift. We'll discuss its benefits and take a look at when we should proceed with a functional approach. We're all well acquainted with object-oriented programming. That's the paradigm that most programmers learn first and utilize in the workplace. And although many new programmers have heard of functional programming, most don't have any experience with it at all. My aim here is not to argue the merits of functional programming over object-oriented programming. Object-oriented programming is flexible, intuitive, and very widely used. OOP is an undeniable part of almost every programmer's life. In fact, we dedicate a final section of this course to object-oriented design patterns. So what is functional programming? Finding a consistent definition of functional programming is tough, but here's how I define it. Functional programming is a style of programming that replaces the concept of objects with a series of stateless, immutable operations. This allows us the flexibility to pass functions into functions and return functions from functions. So what are the benefits of functional programming? For most of us, the real benefit to adopting a functional style is that our programs can be broken down into smaller, simpler pieces that are both more reliable and easier to understand. When do we want to use functional programming? Functional languages are ideal for when you have a fixed set of things, and as our code evolves, we can easily extend our functionality by adding new operations on existing things. That said, we can always use functional programming concepts within OOP. I've got more to say about functional programming in general, but in the interest of brevity, I'll forego further digression here. If you're interested in reading more or finding links to additional resources on functional programming, you can visit this video's resource page. Let's dive into some functional code to see what we're talking about. The goal of this demonstration is to look at what a functional programming solution might look like. So having said that, we won't be going into great detail here. Don't worry if you don't understand everything now. We'll break these concepts down in the next section. Open up Xcode and create a new playground. Name it Functional and click Next, and then Create. I'll go ahead and paste in some starter code and explain what we're going to be building in this demo. In this hypothetical situation, we're managing a business account where we're receiving payments for an iOS application in the App Store. We have an array of dictionaries with deposits, and another one for business-related withdrawals. We also have a dictionary containing our business partners, along with the percentages we pay them for their contributions to our app. Our goal here is to use the data provided to figure out what our net income is after all of our expenses. We'll start by adding a function called findNetIncome. In order to calculate our new net income, we need to add up all of the withdrawals and deposits associated with our app. Since we'll need to calculate them separately, this is a good use case for a new function. Here, we've added a new function named appTransactions that takes an array of dictionaries and returns a double containing the sum of our transactions for the given transaction type. We'll add a property named gain, which we'll call our appTransactions function, and we'll pass in our deposits array. Then we'll create another constant named loss, which will also give the value of appTransaction, this time passing in our withdrawals array. Next, we'll create a constant named net that holds the difference from our loss subtracted from our gains. Now we have to address paying our partners. We'll modify our findNetIncome function to take a closure named payPartners. This closure takes a double and returns a double. We'll need a function to handle our closure. Here we've added a function named payPartners that calculates what percentage of our net gain that each partner is entitled to, combines them, and returns the sum. Let's add a return value to our findNetIncome function that returns the difference between our net value and the result of our partner's closure. All that's left now is to call our function and find our net income after expenses. Add a new constant named income and give it a value of findNetIncome. We'll add a trailing closure with a variable named total, and then we'll return our payPartners value. Finally, we'll print out our income value. Again, we went through this quickly to see some functional programming in action. Now, don't worry if this wasn't all familiar to you. This was just a review. We'll be breaking down functional concepts in the next section. However, if this exercise was completely alien to you, please head over to this video's resource page for some additional exercises on functions, which should help bring you up to speed. We'll be taking a more functional approach throughout this course, starting in the next section, where we'll build a classic programming exercise called Game of Life. In this video, we introduced the concept of functional programming and discussed some of its benefits. In the next video, we'll introduce protocol-oriented programming, which nicely complements the functional approach.